Hello, can you hear me?
Yes, ma'am.
Yes, ma'am.
Okay, can you see my screen?
Yes, ma'am.
Okay, so today we will see some case studies involving PCA. We have already discussed need of PCA and application of PCA. We have also discussed the mathematical theory involved in PCA. So today we will try to see PCA in practice. Okay, so we have we will be studying two data sets. One of them is a typical textbook data, and the other one is some real example. So, I'll also be discussing R commands which give PCA directly, but as I told you, ideally I would suggest not using those commands in this semester. Okay, I'm telling you these just so you should know, but I would suggest that as of now you should try to write codes from scratch, and in the coming semesters, in third or fourth semester, when you are working on other assignments or projects, then only you should use direct commands. Okay, so the first data set is the one which I already mentioned yesterday. It is data sets related to notes. We have two we have two groups. One is fake notes and another is genuine notes, and these are the variables. Okay, length of the note, then left height. So left height is basically height of the note measured on the left side. Similarly, right height, then lower margin, upper margin, and diagonal. Okay, what do you expect? Left height and right height should of course be very similar, because our note is supposed to be generally a rectangle. Okay, so left height and right height readings are supposed to be very similar, and here I have printed first few rows and you can see that that seems to be the case. Okay, so 131 131.1, which means that there is hardly a difference of 1 millimeter, sorry, zero point 0.1 millimeter, not 1 millimeter, zero point 0.1 millimeter, because these readings are in millimeter, right? 130, you can't have a note which is 131 centimeters, this is 131 millimeter. So hardly a difference of zero point 0.1, or sometimes, for example, see here, zero point 0.3 millimeter. Okay, we have to see if these dimensional measurements, they can be used to decide whether a given note is genuine or forged. Okay, that is our job. Generally, any data analysis exercise should generally start with exploratory analysis. Okay, so we will do the same thing here. We compute summary statistics. So these are summary statistics. So we can see that length is of course larger than height, and lower margins and upper margins are comparatively very small, because lower margin and upper margin is the distance between the edge of the note and printed area, right? So it is a very small part. So it has quite low values. Okay, then we also compute standard deviation. All these readings are in the same unit, all these readings are in millimeter. So we have computed standard deviation, and the command that has been used is apply. uh, does everyone know how to use the command apply command? Is everyone comfortable with that command? Yes or no? Is there anyone who has not used this command? Am I I still connected?
Yes, ma'am.
Okay, so this yes was answer to am I still connected. So is there anyone who has not used apply command?
Yes, ma'am, I haven't used.
Okay, so this apply command is generally used when we have a matrix and we have to repeat some application. I mean, we have to apply some function to say every row of that matrix or every column of that matrix. Okay, so here we want to check variance of each variable. So for that, what we are going to do is we are going to compute SD, that is standard deviation, for each column. So if I want to do it for each column, I will say apply bn is the name of my data banknote, to SD. So 2 indicates that SD should be computed for each column of bn. If I wanted to compute standard deviation for each row, I would write it as apply bn1 SD. Okay, instead of this 2, I would use 1 if I want to apply this function to every row. Now we can see here that lower margin has the highest variance and second highest variance is diagonal. Correct. It is interesting to see that mean of lower margin is pretty small. Lower margin and upper, in fact lower margin has the smallest mean, still it has highest variance. Okay, so we have to remember this because later when we try to interpret the results of PCA, this could have some importance. So remember, lower margin has the highest variance and diagonal has the second highest variance, and height, left height has the lowest variance, length has second lowest variance. Okay, now we have computed correlation matrix to see whether whatever we expect is it true. So we said that left height should be pretty close to right height. Interestingly, even if I say pretty close, the correlation is 0.74. Okay, correlation is not like 9.9 or something like that. So ideally we expected nodes to have same left and right height, right? But still correlation is not that high. Correlation is 0.74. And array, okay, so correlation is not that high. This is another one of the comparatively large correlation values, right height and lower margin. Okay, we can also see pairwise scatter plot, which is also known as matrix plot. You might have seen this in multiple linear regression. Have you seen matrix plot? You know how to read or interpret a pairwise scatter plot or a matrix plot? Yes.
No, ma'am. Can you explain?
Okay, so see, I have 1 2 3 4 5 6 variables, so I get a 6 cross 6 plot. So in this particular graph, my x axis is left height and y axis is length. So this graph is of left height and length. Similarly, this graph is of left height and right height. Now you can see here, this and this, both these graphs actually are kind of mirror images, because on this graph also x axis is left height and y axis is right height. So this matrix plot is actually a symmetric kind of plot. So you can focus only on either the upper triangle or the lower triangle, and that is enough. Okay, so if I check this particular graph, okay, so this graph, you can see my cursor moving, right? You can see the arrow moving.
Yes, ma'am.
Yes,
Yes.
ma'am.
So this particular graph is corresponding to upper margin on x-axis and length on y-axis. Okay, so this is a graph of upper margin and length. So basically it is just a collection of all scatter plots for all possible pairs. So because I have 6 variable, I will have 6 choose 2. 6 choose 2 means how many? 15 graphs, correct? So let us see here, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. So I have 15 graphs. Okay, so all possible pairs are plotted to see if there are any relationships. And of course left height and right height had the highest correlation, so we can see some trend here. Others do not show much trend. Okay, now let me go to the actual principal component analysis. We know that here all the variables are recorded in millimeter. Okay, so all the variables are actually in same unit. If all the variables are in same unit, then we can simply use covariance matrix. We don't have to go for correlation matrix for carrying out PCA. So we use this command printcomp. Printcomp is a command to carry out PCA on this banknote data. We want the scores. Everyone remembers what the scores are? We want the scores, so we give scores equal to true and we give core equal to false, correlation equal to false, because we are going to go ahead with covariance matrix. Okay, we don't want to worry about correlation since all the variables are measured in same units. Okay, now this gives me standard deviations for principal components. These are now not the standard deviations from the original variable. You can see comp1, comp2, comp3 written here. So we know, we have seen in the theory that the first PC is of most importance. So of course, why? Because variation is information. So first PC has the highest value of variance. Second PC has second highest value of variance. So basically the components are arranged in the decreasing order as per their variance. Okay, so far? Now we know that we can decide number of important PCs or number of PCs that should be retained via scree plot. Okay, so we plot P. When we give plot P, so in P I had stored the output of this print comp. It automatically draws the scree plot for me. I have given type equal to lines because otherwise it won't join these by lines. It will give I think vertical bars or bar plot type of structure, which we don't want. So I have given type equal to line. Now where do you see elbow? So now you may see that the subjectivity. Some people might feel that this is an elbow at component 3. Some people might feel that this is an elbow. Okay, but normally in such a case I would prefer to call this as an elbow, because after this the the distance between x-axis and this curve is more or less constant after this point. Here I can still see some significant difference. So we would say that this is an elbow at component 3 and hence first and second PC are important. Okay, that would be our conclusion. First and second PC are important. Okay, so far?
Yes, ma'am.
We also had another method for deciding number of important PCs, which was based on cumulative proportion of variation or percentage variation explained by different PCs. So that can be that is also given by R if we print summary. So by the way, what is the use of this command? Options digit equal to 2. Any idea what is the use of this command? Okay, that's a homework then. Try to find out what this digits equal to 2 does. Okay. So summary of P is printed here. We saw these were the standard deviations. So square of these would be variances, and proportion of variance explained by first component would be variance of first component divided by sum of all the variances. Then this would be variance of second component divided by sum of all variances. So you can verify these calculations, and cumulative proportion is of course simply cumulative sum of this vector. So we can see here that the first PC explains 67% of the variation. First two PCs together, means first plus second, two PCs together explain 88% of the variation, and so on. Okay. So if I want, so if say someone asks me how many PCs are needed for explaining 85% variation, then my answer would be 2. Okay, because first if I take just one PC, I am getting only 67% variation. What I want is 85% variation, so I should go beyond 85. So if I go till 2 PCs, then I get 88% variation. So I will say that if you want to retain PCs which explain 85% variation, then go ahead with 2 PCs. Okay, the two principal components. Now these are other things that could be extracted from the output of printcomp command: loadings, center, scale, etc. So loadings actually gives me the coefficients for PCs. Okay, loadings will give me the coefficients. So we will see first two, because from the scree plot we have established that first two coefficients, first two PCs are of importance to us. Okay, so we will see coefficients for the first two PCs. So which variable do you think is important if I look at the first component? If I look at the first component, which variable do you think is the most important?
Lower margin.
Lower
Lower
margin.
margin.
Correct. So because magnitude wise it has the highest value. Now if I go to second component, then I'll have to ignore lower margin. So among the remaining, who is highest? So upper margin. And we can see that diagonal also has pretty high coefficient in both the PCs. So generally I would say lower margin, diagonal and upper margin are most important variables. Okay, most important variables the from the perspective of understanding the variation. Okay, yesterday we talked about principal component regression. So we said that we will use PC1, PC2 scores as regressors. Okay, but when I want to decide which is the most important regressor in PCR, I need not say PC1 as the most important regressor. Okay, because when I am saying that certain variable or certain principal component is important, it is purely from the point of view of explaining variation in the data. Okay, if you have another response like in principal component regression, then important regressor has to be decided by checking correlation of that response with all the PCs or all the regressors. Okay, so please remember that when I say some variables are important or some components are important, that is purely from the purpose of explaining variation in the data. Is it okay? Is it clear?
Yes, ma'am.
Okay. Now let me check the Okay, so is it expected? Why is lower margin important? I had told you something. I had told you to remember this. See, lower margin had the highest variance, if you remember. See, lower margin had the highest variance, then diagonal also had high variance, and upper margin. So basically these three variables have comparatively higher variances than the other variables. Other variables have much lower. You can see here, right height has the fourth number, but right height variance, standard deviation of right height is half that of upper margin, half that of the lowest among these top three. Okay, so it means that principal components tends to pick those variables which have high variation, because the key message is variation is information. Okay, now oh, I'm not, I thought someone entered, I don't know. Arey? Yeah, okay, that's what I thought. Okay, so now that we have carried out analysis, we want to see the score plot. So for drawing the score plot, we need to see the scores. So what are the scores? Just a minute. So while giving the printcom command, we had given scores equal to true, so we would automatically get scores by this $scores. We want to focus only on first two pieces. We want to draw bivariate plot, so we take first column and second column of the score matrix, and then we draw a plot. After drawing the plot, we give the colors. See, even if I did not have colors here, I could still see two groups. If I did not have colors, different colors and symbols, still I would be able to see two groups. Of course, I would put this observation with this group, but I would still be able to see two clear groups. Is it okay? Is everyone agreeing with me?
Yes, ma'am.
Yes, ma'am.
So now the score plot already tells me that yes, there are possibly two groups. What we would want to verify is whether these two groups correspond to the groups in my data, that is genuine notes and forged notes. What I know is first 100 notes are of one type and next 100 notes are of other type. So now we give colors to those groups which are already known in the data. So we give first 100 notes black color and next 100 notes red color. Similarly, we give PCH equal to 17 for first 100 notes and PCH equal to 18 for the next 100 note. PCH is type of this, so triangle or a diamond, or okay. And we can see that except for this observation, the groups are pretty well separated. So we can say that yes, the principal components can actually differentiate or distinguish between genuine notes and the forged notes. Okay, how is it helpful? When a new note comes, I would take its reading, I would measure its length, width, height, whatever, right height, left height, upper margin, lower margin, diagonal, etc. Then I would use the coefficients here. Okay, loadings are coefficients, so I would use these coefficients to compute value of PC1 and PC2 for that particular note, and then I would see on this graph where can I actually plot that? Okay, and suppose that value turns out to be somewhere here, then I will say that that note is very likely to belong to this group. Okay, second group. Is it okay? Then we have Biplot. Okay, yesterday I mentioned in brief about Biplot. So this is a Biplot of that data. Let me, okay. So we can see here I have indicated the groups by letters. So GG is for genuine and F is for forged or fake note. So we can see the two groups. And now we can see left height and right height are almost overlapping here. The two arrows very small and they are almost overlapping, which shows that they are highly correlated. Compared to that, the length of a lower margin arrow is highest because it has largest variance. Compared to that, these lengths are very small, okay, because these variables had very low values of the standard deviation. We can also see that diagonal and lower margin are probably negatively correlated. Upper margin and lower margin are probably not much correlated. Let me check it in the correlation matrix. We have somewhere correlation matrix. So upper margin and lower margin, correlation between upper margin and lower margin. See, it is 0.14, very low. So it is the angle is close to 90 degree. Then what did we say? Diagonal and lower margin, negative correlation, so the angle is obtuse. Okay, minus 0.62, so the angle is obtuse. Diagonal and upper margin, minus 0.59. So diagonal and upper margin must also be an obtuse angle. Yes, diagonal and upper margin, this is also an obtuse angle. Okay, so these things are verified from the biplot. Then we said that group towards arrow has higher readings. So fake notes or forged notes probably have higher values of lower margin than genuine notes. On the other hand, genuine notes probably have higher values of diagonal than the fake notes. Upper margin is also high for fake notes. So let me see if I have, yeah. So here I have computed means as per the two groups. Okay, I have used the function aggregate. This is another interesting function, because so we have this banknote data and then I wanted to have a group label. So I have created a vector gf which gives group label as forged or genuine. Okay, and then we are computing mean. So applying function mean, we are computing mean of this new banknote data as per gf. Okay, so dot tilde gf. Dot tilde gf means mean of all the other variables. So dot represent all the other variables. Tilde gf means with gf as a factor. Okay, with gf as a factor. And we can see here, see, for fake notes, lower margin is higher, upper margin is also higher, which I explained just now in the biplot. What was the other variable? Diagonal. Yes, diagonal is higher in the genuine notes. Okay, diagonal arrow is towards the genuine note group, so diagonal is higher in the genuine notes. Okay, okay so far? Is it okay so far?
Yes, ma'am.
As I said, this was a textbook example. So here things are supposed to work out well. Okay, generally when people write textbook, they try to locate data sets for which everything is perfect. In real life, things did not work out so well. So here is one real life example. So the first one was from notes. Now this is from biology. Okay, so this is an example involving frogs. Okay, so we have some frog with this genus Eupsophus in the temperate forests in southern Chile, and there are actually 4 different species of these frogs. So E. vittatus, E. roseus, E. migueli, and E. calcaratus. Okay, so all these are belonging to same genus, but there are 4 different species. And scientists would like to see if these species are different, means if there is a difference in the physical morphological measurements, morphological characteristics of these 4 species. So a scientist knows how to identify the species, but they would like to see if the differences could be explained more clearly. So these are the variables that they had measured on these frogs. So there were around 120 frogs which were collected, out of which 108 were mature male specimens, and the measurements are taken on these 108. The juvenile frogs have not been considered. And what were the measurements? Here you can see count for each species. So 34 frogs for one, 20 frogs for the other species, 24 for third, and 30 for the fourth. So TLNG is total length. Total length from snout to the upper margin of cloacal opening. So where is snout and where is cloacal opening? You can see the pictures. So snout is here, like the nose like part. So from here, so total length is actually this complete length. Okay, you can see 8 is cloaca, 8 is here. Can you see 8 here? So this complete length is total length. Then next is head width, measured at mid tympanic level. So tympanum is 3, tympanum is here. Okay, somewhere here, this small circle is tympanum. So at this, if you measure head width, then that is head width. Then tympanic diameter. Okay, so you can see the tympanum here, circular type of, small circular type of thing. So you measure its diameter. Then nostril to eye distance, shortest distance from posterior edge of nostrils to anterior eye opening. Okay, so nostrils, you know the location, this is nostril, so nostril to eye distance. Then eye diameter, distance between eyes. Tibial length, tibia, what is tibia? You remember biology, what is tibia? Hello, tibia, fibula, do these words sound familiar?
No, ma'am.
No? Okay, now this is homework. Google what is tibia and Google whether humans have tibia. Okay, so here anyway I have given the diagram. So sixth is tibial gland, so tibia is somewhere here, that should give you some hint. Okay, tibia is somewhere here. So tibial length is external measurement of the tibial section of the limb with joints at right angles. Okay, so you measure this particular length. Then foot length, foot length is distance from distance from the tip of largest finger to the distal extreme of tarsus. This is another word you should Google unless you know tarsus. Okay, so foot length is measured. Then distance between nostrils, nostril to snout distance, all these measurements are taken. Why I have listed all these measurements? First thing, you should appreciate the data. You know, people, biologists, they have taken these measurements, means how much efforts they have to take. See how many variables have they recorded. uh, I haven't given count. Okay, 1 2 3 4 5 6 7 8 9 10. So 10 variables for 108 frogs. So see how much time and efforts they have to spend on taking these readings. So when, you know, when statisticians say that okay, I need more observations, you I I admit that our method requires more data, but we have to appreciate the efforts by people who are collecting these data sets. Okay, for them it is not really very easy catching a new frog and measuring these many things. When you say okay, I need 20 new frogs, it's not that easy. Locating frogs of right species, catching them, and then measuring all these things with precision, it's really a difficult exercise. I'm sure many of us don't have that patience. Okay, so that's why I want to give that's why I wanted to give this picture, because you should understand how much time they spend on this. Okay, so now this there are 11, it seems. Either I have forgotten one or I counted wrong. Okay, so each 11 traits were measured. Yeah, it is written here. 11 traits were measured in millimeters. So all the readings are in millimeters. So we could go for covariance based PCA. So this data is real data. Okay, I did not cook up this data, or it is not from any cooked up textbook. It is real data. So PCA was run. So the scientists who analyzed this data, they chose to use correlation matrix even though all the readings are in millimeters. You will see that sometimes when you want an index type of interpretation for first PC, correlation matrix turns out to be better. What do I mean by index type of representation? It will be clear in a minute. So this is the proportion of variation explained by PCs. You can see here, out of 11, first PC itself explains 75% variation. Okay, this is quite incredible. I have 11 variables, but the first PC itself explains 75% variation. Next PC suddenly is dropping to 10% or 11%. Okay, now if you look at the coefficients, see, in the first PC, except for foot length, all the other coefficients are pretty high. Okay, all the other coefficients are pretty high. So this is what I mean when I say that if you want first PC to be like an index, generally whenever you carry out PCA on the basis of correlation matrix, this is expected to happen, that PCA based on correlation matrix generally leads to the first PC as kind of like weighted mean of all the variables. You don't get just one or two variables as important. You get almost all the variables as having equal importance. Okay, so these are coefficients of the PCs, and you can see that in second PC the highest coefficient is for foot length. Okay, the largest coefficient is for foot length. Now when you draw a score plot, this is a score plot. This is not very clear, I know, but I have copied it from that paper, which is very old paper, so it's not very good picture. So in score plot you can see three groups. Okay, you can't, even though there were originally 4 species, the symbols have been given as per species, so you can see 4 types of symbols, but you can see that these two groups are kind of mixed with each other. Okay, whereas this group and this group is clearly separated. So triangles is what? E vitatus. So now triangles, what do these triangles denote? These triangles denote that PC1 values for these frogs are high, they are positive, whereas PC2 values are near 0. Okay, PC1 values are positive, whereas PC2 values are near 0. And circles are E calculatus. For circles, PC2 values are high and PC1 values are low, they are negative. Okay, so what does it mean? What is the interpretation of this? So this means, see, a very distinctive cluster of stout mid-footed. So other things, so total length, head width, head length, tympanic diameter, etc. So all these are length type of measurements. So generally large and broad, that is stout frog, would have higher values of PC1 except for foot length. Okay, so this group, the triangle which has high values on PC1 and average values, near 0 values on PC2, PC2 is near 0 because this is correlation matrix, right? So these are scaled variables, so near 0 means average. So that's why this group indicates that these frogs are stout and mid-footed. Their foot length is moderate, it is not too high, not too low. So E vitatus species can be characterized as having stout build and almost moderate foot length. Okay, now here E calculatus. So this group, the first group here, I mean the circles. So here first PC is negative, right? First PC values are negative. So they are slim, they are not stout. But second PC is positive values, so they are large footed. So E calculatus indicates slim, large footed frog. Okay? Is it okay so far? And now this group is slim and short footed, but you cannot further distinguish between these two species. So Roseus and Migueli, these species are not distinguishable at this point. But the scientists didn't stop here. They said that okay, we could get characterization for these two species, fine, but can we go one step ahead and get characterizations for these? So what they did was, they took data on only these species, these two species, which are non-separable, and carried out PCA on that subset of the original data. Okay, so second PCA was run on the Roseus Migueli data, which is subset of the original data. Now this is the proportion of variation explained by that. Here the distribution is not that extreme. First PC explains 46% variation, second PC explains 17% variation, and so on. And now these are the coefficients for new PCA. You can see here, except for tympanic diameter, nostril nose, nostril to eye, and eye diameter, these four are having lower coefficients, others have high coefficients. So these four are facial measurements, correct? These four are facial measurements, whereas others are not facial measurements. And now if I draw the score plot, I can see two groups again. Okay, of course there are one or two outliers. See, this is an outlier. Similarly, these are kind of like outliers, but I still see more or less clear separation between the two groups. The first group, now you can see here, along the x-axis there is almost equal spread. So first PC is not that helpful, because you see both the species on both the sides of both the parts of x-axis. What is distinguishing is second PC. Okay, second PC. So in second PC, what is important? Tympanic diameter and nostril to nose distance. Okay, so this indicates now the star is E Migueli. So E Migueli has positive values on second PC. So it indicates that E Migueli has a broader face. Face, because these are only facial measurements. So E Migueli has a broader face than E Roseus. Okay. So among the slim, short-footed frogs, if you want to distinguish further, you have to go for facial measurements, and the broad face would indicate E. migueli species, and comparatively slimmer face would indicate E. rosea species. Okay, so this is how PCA has been applied to characterize the frog species with the help of their morphological measurements by zoologists. Is it okay? Is it okay?
Yes, ma'am.
Yes, ma'am.
So this was a case study involving PCA. I think here I would stop my discussion of PCA. We have had enough discussion in terms of theory. In practical, you would of course learn a few more things. Let me stop here. Thank you.